Hey everyone, today we're talking about something huge, a major shift in how modern labs get things done. We're moving past all those separate, clunky software tools and stepping into a new era with something called a laboratory operating system. We're going to take a deep dive into a really fascinating example called TARE. So let's get into it and see how this new kind of operating system is set to completely change the game for scientists. Okay, so if you've ever worked in a lab, this quote is going to hit you right where it hurts. It just perfectly nails the daily grind, right? You're juggling different software for your notes, for your inventory, for your data, and it all leads to mistakes. You end up with a system that feels totally disconnected from the actual science you're trying to do on the bench. This is the problem. This is the chaos that a new wave of tech is trying to solve. For years and years, the way things worked was pretty much this. You had your electronic lab notebook, your ELN, over here, and your lab information management system, or LIMS, way over there. And what did that create? It created these digital islands where all your critical information gets trapped and isolated. TARE was built to tear down those walls and finally put an end to all that digital chaos. So, how do you even begin to fix a mess like that? Well, the big idea is to stop thinking about individual apps and start thinking about an operating system for the entire lab. Think about it like Windows or Mac OS for your computer. A LabOS is designed to manage the whole laboratory environment, from the software in the cloud right down to the physical instruments on your bench. Okay, so let's really look at the words here because this is important. A LabOS isn't just a passive database, like a digital filing cabinet where you store stuff. The key words here are AI-native and actively orchestrates. It's designed to be a living system, an active partner that helps run the lab, making sure everything from safety protocols to data integrity is all woven into one single unified system. And we're not talking about some simple little app here. The scale is, well, it's massive. TARE is built on top of more than 135 API endpoints. Think of these as individual communication channels that let it talk to and control every single part of the lab. This covers pretty much every facet of your operations: inventory, safety, data analysis, compliance, you name it. It creates this incredibly comprehensive foundation for the whole research environment. Okay, but with all that power, you've got to have a way to keep things organized, right? Otherwise, you just trade one kind of chaos for another. So one of the first things TARE does is bring a whole lot of clarity to how we talk about scientific work. Because let's be honest, words like project, experiment, and case get thrown around all the time, and it can get pretty confusing. And this is where it gets really smart. The framework makes things immediately clear. For instance, a project might be something big, like developing a new cancer drug. An experiment within that project would be a specific task, like testing compound X on cell line Y. And then a case, well, that's for when chain of custody is everything, like in a forensics lab analyzing evidence for a trial. This simple distinction makes everything predictable, organized, and way easier to audit. Okay, so we've got the structure down, but how does this whole system actually, work? How does it deliver on that promise to change the game? Well, we can break TAR's whole approach down into three core pillars that all work together to create this totally new kind of lab environment. All right, pillar number one, the forensic trust engine. This is the bedrock of the whole system. It's all about creating a digital foundation of trust that's basically unbreakable, ensuring every single piece of data and every action is authentic and verifiable. And in some labs, that's just non-negotiable. And look, this is so much more than just keeping a simple log of what happened. We're talking about an immutable, tamper-proof record of every single thing that happens. Database triggers physically prevent data from being changed or deleted. Everything from moving a sample to writing a notebook entry is cryptographically signed. The whole system is built to be so robust, it's literally designed to stand up in a court of law. But here's the cool part. All that security doesn't mean the data is locked away in some vault you can't access. This screen shows how you can actually interact with that fortress of data. You can search the entire immutable audit trail using plain English. You can literally just ask it a question like, hey, show me what changes Kevin made yesterday. It makes forensic-grade compliance actually accessible and useful. All right, let's talk about pillar number two, the AI copilot. This is where the platform stops being just a tool and starts becoming an active partner, a teammate. It's woven into the very fabric of the system, designed to help researchers out at every single step. And this isn't just some clever chatbot bolted on for show. The key here is that it uses your lab's own private, secure data to give you answers. So when you ask it something, it's not guessing based on the internet, it's referencing your own past experiments. It can help you design protocols, analyze your notes, and that neural interface, total game changer. You can be hands deep in an experiment and just say, TARE, start a 15-minute timer. No touching anything. And that brings us to the third and final pillar, which is all about active safety and operations. This is about moving away from just having a safety binder on a shelf and toward a system that is actively looking out for you, helping to prevent accidents before they even have a chance to happen. So, imagine this. The system is always watching. You go to put two chemicals that really shouldn't be together in the same cabinet, it's not going to let you. It'll flag it right then and there. It enforces the rules on how much hazardous material you can have, and it can even connect to sensors to monitor things like temperature and air quality. It's like having a digital safety officer on duty 24/7. And this right here is what that looks like in the real world. This inventory dashboard isn't just a static list of your stuff. It's intelligence. It automatically tells you, hey, you're running low on this reagent, you should probably reorder. And it highlights hazardous materials, making your day-to-day work so much safer and more efficient. Okay, this all sounds amazing in the digital world, but a lab is a physical space, right? So how in the world does a cloud platform talk to a physical label printer on your bench? Or a microscope? That's a huge security and logistics problem. Well, the way CARE solves this is actually pretty brilliant. It's a three-step process. The command starts in the cloud, then it travels through this super secure private tunnel. It's like a VIP lane on the internet that nobody else can get into. And finally, it arrives at a little gateway device in your lab that actually carries out the physical action. This interlock protocol is a genius way to bridge that digital-physical gap without ever exposing your sensitive lab equipment to the dangers of the public internet. So, with all this amazing tech, we're left with one final and honestly, really important question. One that anyone who works in the real world, with all its messiness and unpredictability, will immediately understand. Right? This is the first question anyone who's ever worked in a basement lab with spotty Wi-Fi is going to ask. If your whole lab runs on a cloud platform, what happens when the internet just dies? Does everything just grind to a halt? And the answer is no. You keep working. Because TARE was built from the very beginning to be an offline-first app. It's designed for the reality that, yeah, sometimes the Wi-Fi just isn't there. So even if you're completely disconnected, you can still write in your notebook. You can still scan your inventory. You can capture your data. Everything you do is just queued up securely on your device. And the second you get a connection back, it all syncs up automatically in the background. And crucially, even that forensic audit trail keeps running offline. And that's what really makes this a true operating system. It's built for the real world. By taking care of all that background noise, the data management, the safety, the logistics, it frees up scientists to just do science. It makes you wonder, doesn't it? What kind of breakthroughs are possible when your lab itself becomes your smartest research assistant?